Hello and welcome to this video for basic sentential logic, informal fallacies, and cognitive biases. In this video, I'll be talking about material corresponding to section 2.7 of the textbook. And in particular, the topic is contingencies, contradictions, and tautologies. So it's often useful to know the range of truth values that a statement can have. And there's three possibilities when we talk about the range of truth values. Some statements can only be true. They're always true no matter what. They can't be false. And we'll call those tautologies. On the other hand, there are statements that are always false. They can't possibly be true, and we'll call those contradictions. And finally, there are statements that can be either true or false. That's a typo there. And we'll call those contingencies. So these are the three categories of statements in terms of the range of truth values that that statement can take. Now, by definition, in this class and in logic, basic logic in general, atomic statements are contingencies because they can be either true or false. But this doesn't mean that all compound statements are contingencies. Compound statements in general, some of them are contingencies, but some of them are contradictions and some of them are tautologies. Now here's an example. You might think to yourself, well, how is it that a statement would have to be true or a statement would have to be false? Can't any statement potentially be true or false? Maybe, and if you're thinking that way, you might think that all statements are contingencies. Well, not really. So look at this statement, P or not P. Now we know from the disjunction truth function that the entire disjunction is true if either disjunct is true. It only takes one of them. The other one could be false. But if one of them is true, or if both of them are true, but it only takes one, then the whole disjunction is true. And if you look at this, you can sort of tell that one of these disjuncts has to be true. Because if P is false, then not P will be true. And if this one is false, this one will be true. So no matter what, one of those disjuncts will be true, and if one of them's true, the whole disjunction will be true. So this statement can't be false. And one way we could sort of see that graphically is to do a truth table for this statement. So here's a little truth table. There's only one atomic statement, so it's true or false. Then we have the compound statement, not P, is the opposite of that, so false, true. And if we do the disjunction here, the disjunction is true when either disjunct is true. Well, here the first one's true, so it's true, and here the second one is true, so it's true. So if we look at this, we can see that no matter what, this disjunction is true. It can't be false. So to determine whether a statement is a tautology, a contradiction, or a contingency, what we're going to do is we do a truth table for that statement, and then we look at its truth column. And this is one type of problem that there will be on the quiz and then also the final exam. You'll be given a statement, and the question is, do a truth table to determine if this statement is a tautology, contradiction, or contingency. So step one is you do a truth table for the statement like we did here, and then you look at its truth column, which is the column of T's and F's under that statement. And then you just see there's three possibilities. It has only T's, right? That whole column is nothing but T's. If that's the case, then it's a tautology, and this one is a tautology because it's only T's. If the truth column has only F's, then that statement is a contradiction. And if it has both T's and F's, then it's a contingency. And it doesn't matter what the proportions are. right? It could be 127 T's and 1 F. As long as it's possible that it could be true or false, then it's going to count as a contingency. Okay. So when we do the truth table, we just look at the truth column for the statement we're interested in. In this case, it's this disjunction P or not P, and we assess whether it's all T's, all F's, or a mixture of T's and F's. So let's do another one. B and not B. Now this is another case where you could determine this without necessarily doing a truth table pretty easily. Okay. Because a conjunction, in order to be true, both conjuncts have to be true, right? But you should be able to tell that it's impossible for both conjuncts to be true at the same time. If B is true, not B is false. And if not B is true, then B is false. So both of these conjuncts can't possibly be true at the same time, which means the conjunction can never be true. So if you were just answering the question, you might not have to do a truth table. In general, though, on the quiz and on the final exam, the question will be to use a truth table to determine it. So you should use a truth table anyway. But we'll see when we do the truth table that we get the right answer. So here's the table. We have one atomic statement, B. There's not B, there's the conjunction. B can be true or false. Not B will be the opposite. If false, false then true. And then the conjunction, in order to be true, both conjuncts have to be true. And you can see that there's no row where both conjuncts are true. So that statement's truth column has only F's. Okay, so that statement is a contradiction. Let's do one more example. Here's one where you might not be able to tell just by looking and thinking about it if it's a tautology, a contradiction, or contingency. If you really thought about it hard, you could probably tell what it is, but we're going to do a truth table anyway. So here's my table. It's got two atomic statements, so I'm going to need 4 rows. Here are the statements. Atomic statements are true, true, false, false, S, true, false, true, false, S or R, true, 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 false. We did this in the last video, so I'm not going to go through this in detail. This is just the negation of that, so false, 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 true. And now we have the conjunction of R and this negation. And you can see there's no rows where both conjuncts are true at the same time. So this conjunction, R and the negation of S or R, in fact, it's a contradiction. That truth column contains nothing but F's. Let's do another example. So you can see this is pretty straightforward conceptually. If you can do truth tables for a statement, that's the only marginally tricky part. And even that's not too hard. Once you've practiced a little bit, you'll be able to crank out truth tables pretty efficiently. But if you can do a truth table for a statement, determining whether it's a tautology, contradiction, or contingency is trivial. Right? You just look at the truth column and you just see, is it all F's, is it all T's, or is it a mixture? And that's it. So let's do another one. If not Q, then it's false that if Q, then not N. Here's the truth table. Remember, as always, we're just going to stipulate, or just as a convention, we're going to do all of the atomic statements in alphabetical order. So even though Q shows up first in the linear order here, alphabetical order, we're going to do N and then Q. So just as a reminder that we're going to do that. So here's our combination of truth values. Not Q is just the opposite of Q. Not N is just the opposite of N. If Q, then not N. So here's the antecedent. Q, not N is the consequent. It's false on row 1. True, false is false. True everywhere else. This is just the negation of that. So instead of false, true, 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 it's true, false, false, false. And then now we have the conditional, where the antecedent is this, not Q, and the consequent is this. So I'm going to look for the rows that make a conditional false, where this is true, but that's false. Row 2, true antecedent, false consequent, and row 4, true antecedent, false consequent. So it's false on 2 and 4, true everywhere else. So now we've got the truth table for the statement, and now it's trivial. Is it a tautology, contradiction, or contingency? Well, clearly it's a contingency. There's a mixture of T's and F's in that truth column. And that's really all there is to it. I'm not going to do more examples right now in this video, just because this part's pretty trivial. If you know how to do truth tables, this test is actually very easy to implement. So that's it for this video. In the next video, we're going to go on to discuss something slightly more complicated, which is relations between 2 or 3 statements. So the topic here was just a single statement and 3 different categories that a single statement might fall into. The next topic will be relations between statements, which is going to require us to do a truth table that has 2 or 3 or 4 statements on it and assess possible relations between them. But that's it for this video. Practice a lot, and good luck.